If-Else-If-Else statements allow us to test multiple conditions, run specific codes in the case that one of those conditions is true, and then put an else block which runs if all the conditions fail. The key syntax involve 4 different keywords. We start with the if keyword, then we follow that with the else if keyword, followed by the else keyword, and then the end statement to show that that statement is concluded or we ended it. Right next to each if and else if statement, we put some condition in the form of a logical scalar. Remember, this is a 1-by-1 array whose truth value is either 0, which is false, or 1, which is true. So we write if logical scalar 1, we have some executable code block 1. Else if logical scalar 2, so if the second condition is true, please run code block 2. If neither the first condition nor the second condition are true, we drop into the else block and we run that block of code in that case. Let's look over at the control flow diagram to kind of describe what's happening here. So in the sequence of code, we drop into the if statement. If the logical scalar, which is the condition we want to test, is true, we run code block 1, and then we go down to end and we continue on in our program. If, on the other hand, that logical scalar 1 evaluates as false, then we drop into the else if logical scalar. So now we test the second condition, which is the first else if statement. If that's true, we run code block 2. Once that's done, we run all the way down to the end of the program. If that is false, we drop into the else condition, and then we automatically run that if all of those conditions are false. Once we're done, we drop to end, and then we go on with our program. Let's see how this plays out with an example that's going to come in handy later in the course. So we will actually go ahead and start a blake.m file, so new script file, or we can go to new, down to script file. I've already kind of done that. Let me go ahead and save this in the proper place, always saving. In this case, I'll just go ahead in my desktop. So I'm going to call this the else underscore if example. Now what we're going to do is just remind ourselves what we're trying to do here. This code develops a test to check if 2 input variables are vectors. Let's go ahead and define those 2 input variables. We'll call A the first one, and for now we're just going to use kind of any code that produces vectors. So this is going to be the vector of all ones. We can go ahead and check that in the command window. Notice it does produce a 10-by-1 vector of all ones. Let's do B to be some other input. We'll call it zeros, maybe 1/8. That's going to be a row vector with all 0 entries, 8 columns, and of course B is exactly what we said it was. We're trying to figure out whether or not the entries of these are vectors. So we have these A and B, and we want to know, are they vectors? And maybe we want to go further than that. Maybe we want to say, we also want to categorize what type of vectors these are. So row or column vectors. So we also want to identify which type of vectors these are, row or column vectors. Maybe the first thing we want to do is say, are either of these things not a vector? Because if we're going to identify rows and column vectors, but one of them is not a vector, that's kind of an issue. So maybe we say, let's use an if statement to start this, and we say, if it is false that A is not a vector, so if A is not a vector, and let's go ahead and write this, or B is not a vector. Remember, the is vector function produces true if it's a vector and a false if it's not a vector. Then we say, let's just go ahead and produce an error message, fprint f. We'll use that famous function that says the inputs are not vectors, right? So in that situation, we've kind of ruled out the situation that both of them are not vectors. So we can assume that if this thing doesn't print this, then both are vectors, right? And then what we want to do, so I guess we could say, one question that I have right now that we should probably test is if one of them is a scalar. So let's go ahead and define the one scalar. And then let's test, is this a vector? It's a logical one. It is a vector. So this includes, in our test, we're going to say that a scalar is both a row and a column vector. We should be aware of that case, especially as we're coming up with conditions to test this. All right, so we kind of know that. All right, so now what we want to do is come up with a different condition test to figure out if they're both column vectors, both row vectors, or one column and one row. So let's go ahead and do if, else, if, else, and then end. All right, so let's test the first one. One thing that we might find useful is to track the dimensions. We're going to use the lowercase letter m to represent the number of rows and the lowercase letter n to represent the number of columns. This is going to be kind of a theme in this course. So what we've just done now is we've said m capital A, that's the number of rows in A. N capital A is the number of columns of A. We can reproduce that code, just reuse the same line and switch this over to B. All right, so now what we want to know is if M A, so let's start with column vectors first. I'm kind of biased towards that. If we know that the number of column vectors is A and is 1, so if A is a column vector, then the number of columns of that should be 1. And if B is a column vector, then the number of columns of that should be 1. And in that situation, we say that both are column vectors. So both variables are column vectors. All right, let's take a look at the next one. So what if we were to say the same situation but row vectors? So if MA is 1 and MB is 1, instead of being column vectors, these would be row vectors. So both variables are row vectors. And then if neither of those are true, so if NA is 1 and MB is 1, both are column vectors, both are row vectors. If both of those conditions are false, then we would assume that one is a column and one is a row. So let's go ahead and do this. One variable is a column vector and the other is a row vector. That's the claim there, right? So we have different tests. Let's go ahead and just run this. We'll start with the column vector situation. So let's run that test. Notice that here we have a 10 by 1. There we've got an 8 by 1. We get the dimensions. We check is either one or the other not a vector? Yeah, this should actually be at least one is not a vector. At least one input is not a vector, right? Because, well, let's go ahead and do this. If A is not a vector, but B is a vector, so this would be false, not would be true. This would be true, not would be false. True or false becomes true, and then we would kick into that condition. So let's go ahead and test that. At least one input is not a vector. That's exactly what we expected. Okay, let's go back here and change it. So now we're kind of testing the logic of our program. Let's run this. In this case, we have a vector, so that is true, not becomes false. True, not becomes false. False or false is false, so we avoid that completely. It doesn't run. Notice that in this case, NA is 1 and NB is 1 because we both have column vectors, and that's exactly what we see. We actually produce this situation. Both are column vectors, and we run that. Let's go back here. Let's switch this to row vectors and test that we get the right output in that situation. So let's say it's a 1 by 8. Let's run it. Both are row vectors because that's exactly what that happens here. Let's go ahead and test if one is a row vector and one is a column vector, and we'll do it in either situation. So that's exactly what we have, right? One is a row vector, one is a column vector. That was the else block of our code. And we could switch those, of course. We could say that this is 10 and this one is 8. So now same thing should run. One one variable is a column vector, one variable is a row vector. We could do more tests like this, right? We don't have to just figure out if one is a row and one is a column. We could be really, really specific. So what if we wanted to add another else if block? So let's do else if. And then what we'll say is the first one is a column vector and the second one is a row vector. So A is a column vector and B is a column vector. So now we're getting really specific and saying what are the dimensions of each one of those. So let's go down here. If the number of columns of A is 1, then A is a column vector, and the number of rows of B is 1, then B is a row vector. Of course, we could run the same condition, but the number of rows of A is 1, and the number of columns of B is 1. So this would be a row vector, and this would be a column vector. And then the last condition that we could check, this must be A is a row vector and B is a row vector. So now we've come up with a 4-condition if-else statement that tests each individual component. So first we make sure that both of them are vectors, and then we figure out whether or not both are column vectors, both are row vectors, or classify which one is a column and which one is a row. Note, this is kind of an important note, scalar variables are both row and column vectors. So that's kind of an interesting part of this. Of course, we have to document this a little bit better, but this is a situation where we're using the if-else statement to come up with different checks on the conditions and then produce different outputs based on that. Community challenge for this video is, can you produce this same type of code using nested if statement? So instead of using the else-if combinations, can you use an if-else statement 1 and then inside each code block use a different if-else statement to produce this exact same test that we've run here? I'll leave that for you viewers. Thank you so much for your attention. In the next video, we'll talk about logical short circuiting, which is exactly what we see here actually. This is kind of a special MATLAB operator that allows us to do what we call logical short circuiting. We haven't talked about that yet in these videos, and that's exactly what we're going to do in the next video. Figure out why the double and versus the single and why the double pipe versus the single pipe. I'll see you in that next video.